So to do that, I'm going to leave this as is, and I'm going to add a new form, which we did last time. So you can close these forms here, and I'm just going to go into the project, add Windows form. Okay, so we have the form 2, and I'll leave it as form 2. You can give a different name, it's fine. So a Windows form 2, add, and I'm now presented with my second form. And then just make sure that this is the default form to run. I need to also go into the project folder, tab, and at the bottom of that menu item is the properties. So click on that properties for the project, and we want to say the startup form needs to be set to 2. Okay, so when you run, you click the run on the start button, it will start from form 2 instead of the default, which is 1. Okay, so save that, and you can close this now. So now when I run, it's going to run the form 2, as you can see here. Okay, so it would choose that one instead. Alright, so let's add a few stuff in here, kind of like the previous one. Add a list box, and we're just gonna add some data here, just like we did with the single dimension, but it'll be a 2-dimensional array here. Button on the top, just like the other one. You can do that. Okay, or if you have, I just want to show you, you can do as well. The cool thing about these is that you can just copy and paste. So if I click solution to show my second form, so let's just say that I didn't have here. Okay, I don't have anything here. Oops, what did I do? If I have nothing here, and I load my form 1, okay, I can copy this, just Control C, and then paste that to a form 2. Okay, so you can see how can I just copy that and put it here. And now form 1, form 2 has the same copy as I had, except these items are now saved into form 2 instead of form 1. Okay, so that's kind of handy, right? And I'm going to remove this, arrange these so it's in the right place, and I can remove form 1. So it saves me some time. And when you do that, you can see all the names, all the formatting, the names, the text, everything is retained. But it's independent now because form 1 has its own, form 2 has its own, because they're 2 completely separate forms. Okay? And as you run, it would still run form 2, except there's no code, so it doesn't work, right? But the setup is there, so that's pretty nice. So we use this same layout here. Okay, so I'm going to go into the show it button here, double click. Well, back to where it was before, except different form. Let me minimize these windows here. So now we're going to create a 2-dimensional array to store some data, and then we'll just print them out. We'll do some type of data manipulation. And so we just have to make sure that when we write our code, you have to have a matching column size. Okay, the row doesn't matter. You can have as many rows as you want. The column is the important key here. So we just do the same thing like you would do any variable name. We could have like maybe like scores of information of data, right? So scores of, if you want to build a 3x3 table, what should I put in here? If it's a 3x3 table, what are the values in here? 3x3. 2, 2. Okay. Yeah, right. That's right, because the size is one more than the index. So it's a 2, 2, but really it's a 3x3 table. including the 0, right? As integer. So scores, and because it's not a structure, the data type has to be the same. Have this only you can only contain an integer in this case. So now we can populate this scores array with some numbers, and by doing this way, since we already kind of include the numbers of 2 by 2 in here, then you will have to populate the scores by going into each of those positions and assign a value. So let's just, the first one is I don't know, 90, okay, and so it's 0, 0, 0, 1, right? Scores of 0, 1. It doesn't matter which order you do, but you kind of usually start with the row first and then the column. So this could be like 95, scores of 0, 2 gives you be like 99. So there is my index for the row would still be 0. I'm still dealing with the first row, but my column is a max now. I already reached the maximum column size because I said the index is 2, so therefore I have to stop at 2. I cannot go more than that. If I do, I have an error. You have a out of bounds exception error. Okay, so I'm done with that. Then I can now move to the next one. So I can copy this again and put it here, and then now I could just change this to 1, 1, 1, and we'll change the values on this side to maybe like just 10 below it, like 80, 85, and 89, right? So it's my first row of data, second row of data, and I need one more for my third row of data. So this would be 2, 2, and 2. And for this one here, we'll just go down the number here, 7, 7, and 7. Okay, so I have a table of 9. So it's a 3 by 3. The size is 3 by 3. So if you just basically row times columns, you get some 9 data pieces of data. Okay, so if it's 3 by 4, you get 12. You just multiply the size, not the index, but the size. So there's our scores table, and then we want to print it out to the list box. So when you do this, right, you notice that I put everything here. You could put this into a function, and so that your code will look much cleaner in here instead of having everything in here. Okay, we could do that, but this is fine for now. Maybe we do that. Let's do this. Let's create a function up here. So you also kind of review what we did last time. Okay, I'll create a function up here because the function will return the data back. Usually you don't have to, but in this case, oh, no, maybe not, because remember that a score is an array. Array is a reference type, right? If you change data, you actually change the data from the original data. So we can use a subroutine here. We'll just say init array. Okay, and we'll pass the array in here of type string. So it will be like scores as integer, and because it's an array, you want to put the parent here. Okay. So arrays are already references, so when you pass it here, you don't have to specify by reference. Okay, you can, but you don't have to, because array is already a reference. Okay, you can leave that as is. And then it's not going to return anything back because we changed the array size. Information here will also be propagated back to the original array out here. So we can move all of these here, cut all these, and put it inside this subroutine. Okay. Oh, okay, it's a two-dimensional array, so I forgot to put here a comma. Okay, so the array here is a two-dimensional array. So just make sure you put a comma here to separate the two. Again, you cannot put the numbers in here. You cannot just say, 2 by 2 array. Okay, you can't do that because it's already sized based on the one you pass into it. So you will leave that out. Just put a comma here for 2 array. If it's 3-dimensional, you put another comma. 4, you just put another one, right? So that would initialize the array with those data, and then it's not returning anything back, which is fine, but the references type here will cause the array to store those data already. And we'll see if that is true. Okay, so now we can call that subroutine called init array in here. So we can say init array, and we're going to pass the scores array to it. Okay, so we just call that, and now it's been initialized. And so the next part is you want to also say another routine called just print array, right? And then we'll pass the scores to that array to print it out. And we'll write a separate subroutine to do that. So in your original code, it will look very nice, much, it's very lean and easy to trace. You look in here, it's a subroutine. Go into that subroutine and then look inside there and then see what the code looks like. Make any errors there. If you fix it, you fix it, and then so you kind of like have a more control of where your data lies. So you are kind of like separating your concerns in terms of the NVC paradigm. So now we need to create a function, another subroutine, because we're not returning any data. We just print it out. Call the print array, and it's going to accept the scores array. It's a 2-dimensional. Put a comma there. As integer type as well. And then we're now going to print this to that list box. Okay. And we can do it 2 ways. We use the loop, the for loop, and then we'll also do one more time with the for each loop. And as you can see, I use a lot with the for loop because that is easier, saves you a lot of time, because I won't forget to increment my variables. If I forget, I can run into the issue of an infinite loop, right? So that's not cool. So in here, I'm going to go ahead and just do a loop, the for loop. I use the I, not I, but usually you call the row. You name it, so it makes more sense. You're going to print the row. You go row first, and then column, row, column, right? I mean, for each row, you do all the columns. You move down to the next row, print all the columns. This is the standard way of traversing the array. So for the row as integer, starting from 0 to, it's 2. How do you get that 2? How do you get that index here? How do you know the number here? The maximum row index, right? So that will be what? The scores, right? You can do like scores. You can't do length here. Okay, it doesn't work. Okay, so it has to be because it's a 2-dimensional array. You want to get each of those boundaries, so upper bound. You have to call this upper bound here to get the correct index. So that will give you the upper bound of the row here, whatever it was set to, or whatever it is currently. And so in this case, you don't have to worry about what that size is. You already know. And if you don't do anything here, in this case, you can if you want to. Usually you do some coding in here if you want, and then you would go to the next. Right? We just print them out. So I have another loop in here for the column as integer. And you don't have to use both for loops in here. You can mix and match, right? You can mix it with a do loop in here if you want, or a while loop, right? It doesn't matter. And with this time, we're going to start also from 0 to the upper bound of the column, which is the second index. So get upper bound again. This time we'll deal with the column index. So we're going to loop through the first row, and then the first row, loop through the columns from 0 to that many columns. Once we're done, then we get out of the loop, the inner loop, go back to the outer loop here, we increment that to 1, and then we start the process all over again. So in here, I just have to really just output to the list box. ls to result that items that add, and I'm going to add the scores sub row and column, row and col. So it's going to print row 0, all the columns for that here, that many upper bound times, and then it will go to the next row, right? So I should save this, and I think we're done with this one. So let's see if it works. And you can run it. You probably end up with more data than the list box can contain, but we will scroll with the scroll bar. And I did not center my form, so that's why, but it's fine. And you click, you see that you have a score of, well, yeah, right, you have the first row, notice we don't separate, so we don't know what it is. But the first row is just, again, it's a 3 by 3, so we have 0, 1, 2, that's the first row here. The next row starts here, this 3, and then the last row here. So if you do this way, it's kind of hard to tell. And you can separate each of these rows by modifying your code. Okay, so let's see that we can do that. So right after you print the first row here, so before you go to the next row, you want to print a separator, maybe like line items dot add, and then not tab, but just a separator to show that that is the end of that row. Okay. And as you will see, that it looks a little bit nicer now, but it's still not really that nice because you only see the data in row wise, right? But we did separate each row's data by its column. So the better way is to really put this into a table. Okay, you can do that by just concatenating this into the single line here, right? So we could fix that, and let's go and fix that in here. So instead of so how would you achieve that? How do you print it so it's in the same line? If I ask you to do this, to build a table, put into that single line of text, single row, so that first item should contain the first 3, it should contain like 90, like 95 and 99 on not in a 3 rows, but a single row. How would you fix this to make it work? So this is what the output is, right? We add that to the items each time. Every time you issue an items.add, it's going to generate that next row of elements inside the list box. So instead of doing this, you would do it differently. Okay, so in that case, let me just comment this out. You would not put that here. Okay, you would maybe like like out here somewhere, like right in here. You would dim a string of text. So str as string, or integer is fine. I guess what should string of well, see string. See if that works. A string, and then in here, instead of putting that into the list box, you would build the string first. Okay, so it would be like string is equals string, the current string, right, plus you concatenate that with the scores of row, column, and then you would concatenate that with some white spaces. You can use the VB tab like you've been using so far. So you put a tab there. So initially there's nothing there yet. So you have a score, tab, and then you go to the next one, tab, tab, and so on. Okay, you can do that like that, or you can say, you can take this out, right, and put it here, and then remove that, and shorten that a little bit, okay? Because whatever the string is, append this whole thing to the current string. And then finally, once you're out of that loop, then you can go ahead and add that to, right, add it to the list box. You can say lst result.items that add. I'm adding just the string now because I'm building the array, the result of the array data into the string. So now the string will look, if you were to print it out, the string will look something like this. So str will look like, you know, what's the first number? 95, 99, 99. So we look like 90, have a tab, 95, tab, and then 99. It will look like that in the string. The first loop through will look like that, and you print the string into the list box, this item here, and then you add a dash. Once you're done with that, you could put that here. We don't need this anymore because it's already, you know, kind of nicely structured that for us. You go to the next row, and then we reset the string again to empty. Okay? Because if you don't do that, it's going to retain whatever it was before, and the string will grow. So you can do that here. You can do it outside, but if you do it outside, just make sure you reset the string to empty. Okay? And then let's see if this works the way we expect. And save and run. And so now we have a nicely structured table. Except something's wrong here. So maybe if you dim the string inside there, maybe that doesn't solve a problem. Okay, so it does have the idea. It's just that we kept the same string in here. I think because we didn't reset the string. So let's do, like, if you move this outside of it, inside here, okay, and once you do that, then we'll set the string to nothing. Okay, you can do that string to nothing, or I think you can put a just like that. Okay, an empty string. It means the same thing, I think. So we can use that. Oh, why is this? Yeah, it should be a lowercase. It doesn't matter because it's not case sensitive. I just want to make it consistent. Okay, let's see if this works. Run it again. And so almost, yeah, it's much better this way. I think if you dim it, you'll retain those same value, which is kind of weird, but. So now we got a table built, and we have a 3x3 square table. And I used the V tab so it can align the data, you know, nicely. Okay, any questions on how we coded this? So you saw how I used that to build that table, right? Later on we learn about the data grid. It's a little bit different, but that will actually give you a nicer layout because the data grid is already a table itself, and you can automatically populate those data into that data grid, especially when you load data from a database table to that grid. Okay, so that's one way to solve this problem, except that I showed you that we use the for loop to achieve this result. and we'll do another one using the for each loop. Okay, so I put here, I'll reprint it again. I'll just say, well, yeah, I'll just put another one here. So it's print array 2. We'll pass the scores to it as well. And this time we're using the for each loop just to demonstrate how that works. So in here, I'm going to create another subroutine. It's going to be called print array 2. Just make sure. Print array 2. It takes in the scores array. It's a 2-dimensional array as integer type. Okay, so this one we use the for each. And for each, it would just loop through every item from the row, every column here, just in this order. So you should get the same result as this one here, but the code is much shorter. So we could say for each item in the array is like what, score, right, or int. So you can say for each score as integer in the scores array. Okay, just like you make it into an English sentence. For each score in the scores array, just print it out, right? But again, if you just print out to the list box, then you get what we saw earlier. It's kind of not nice. So again, we could do the same thing. We say dim string as string, and we set that to that there. And then in here, you can do like string the thing is that if you do that, you don't know where to stop, right? Because the for each, as you can see, before we do that, let's print to the list box so you can see what it looks like. So result items, add, and if you just put the score, okay, so the score here will know what to grab. LED takes care of the indexes for us. So it will grab the first item and add it to the list, and so on. So if you look at this, you will see that you have just a long list of the numbers right below here, right? You get the same results we had earlier initially, because now with the for each loop, it prints everything out. If you look at the order, it's the same. So 90, 90, 95, 95, 99, 99. And then here we need to stop and then move to the next row. So if you want to format this out to look just like this using the for each loop, it's a little bit tricky, right? You have to count numbers. So I mean, just in terms of formatting, then you have to take care of that in here, and you need a counter. Okay, and so I would do, like, for example, I'll do like, you need a counter, so then int, to say count as integer will be 0 first, and for each score you're going to count plus 1. Okay, actually before you count, right? Well, you start from 1. Yeah, it doesn't matter how you do it. You can do that count first, or after, it's fine. Let's just say count 1. Count 1. So we add that to the list. Not the list, but we're going to add it to a string. So string will be strings. Go to string, concatenate that with the score at the VB tab. It will look like that. If you don't count and terminate, it will will look different. So we do that until we reach the end of the count is 3. The first time is 1, then we increment that to 2, and then increment that to 3. So once we reach the 3, then we want to print that out to the list box, and then we go on. Okay, so now you need to check like if count is equal 3, right? Then you can now print the list box items that add the string. After that, you want to reset the string to blank, right? So all over again. And then you also want to set the count back to 1. Or even a 0, however you choose to do it. So you can see how complicated this can get, right? Maybe 0, because when I do a 1 here, it goes through. At the end of that, I want to change the count to 1. Okay. This may not render correctly, but we'll see. So this whole part just to print the string, the first 3 items on a single item, add that to the list, you reset the string, and then you set the counter again, so that when you increment a counter and when it reaches 3 again, you move to the next row already. And we'll see if that works. Okay, so you can see here, this is the for each loop here. I should have filled the separator there, but as you can see, it prints out the first is 0. Okay. So it has a 0 counter. It prints this out, and then it is not equal to 3. We skip this part. We increment that to 1. So now it's 2. And we print that. We add it to the string. Next is 3, and then we add it to the string, and it's 3. That's true. So we're going to print a string which looks like this to the list box. We reset the string to nothing. We set the count back to 0 again. And then the reason why 0 is not 1 is because down here we increment that by 1 already. Okay, so we start all over again, but this time it moves to the next row already. Okay, so it's much harder this way if you're using the for each loop. For formatting purposes, right? You have to care about the counter, and you can't just like stop there or something because you don't know where it is. Okay, whereas if you use that in the for loop, it's much easier because you control the counter here for each of those by the column counter or the row counter. Okay. This is the for loop, so you can see if I take out the comment, the code will look like that. Right? Looks kind of nice. Not that many lines of code. But what if you want to write this using the do loop? What do you think it looks like? Let's do that. So you can get a hang of all the loop as well. Let's do a print 3. Okay? So print array 3. Has the scores again. And so let's do using the do loop. And so you can kind of see the advantages using all those loops. So here it's going to be a sub print array 3. Same thing, scores, comma, as integer. Okay, so now we'll just deal with the algorithm first. Let's forget about the formatting issue for now. So I needed 2 do loop, right? One for outer, one for inner. So that means I need a counter. I need to create a counter for the row as integer. I'll start that from 0. Right? You need one for the column as well. And the same as the for loop, you need 2 of those. So those are declared outside of the loop because You can't add that to the head of the loop and the do loop. Not only that, I need to know the row index, right? And also need to know the column index. So you can see I need to have all those variables taken care of. So the row index, I can get that directly from the array. So equal array of scores dot get upper bound 0, right? That's the row. The column is scores get upper bound 1. So those are my indexes, the maximum index. So once I get those squared away, I can now do my do loop. So do while. So I have one there. Okay. I have another inside here, do while. I have two loops going on, right? For now. So what do we put here? If you're going to do the row first, so you can say what? We do exactly like same down here, like rows and columns. So what should be the condition here? Anybody want to give us a hint? What am I looping through here? So it's the same like the outer loop and inner loop. So if you choose to do with the row wise, you can say, well, you want to compare the row, right? The row to the row index. Okay, we're looping this here from 0, starting from 0 to the index, which is the maximum index in this case. So we want to make sure that it's not, you know, exceeding that row index. So we say while row is less than or equal to row index. Okay. And then here will be the kind of same, except you do column here. So let me ask you this question. Why do I put an less than equal and not just a less than here? Assume you want to print everything out. I mean, does this make a difference? Well, of course it does, right? Okay, so you put an equal sign here because you know that you want to include the maximum index. Again, this one here gives you the maximum index. Okay, so what do we set? We said it was 2. So it's going to give you that 2. And the 2, that's what we need to know. Okay, whereas if you were to say, if I didn't use this, you know, initially if you put like scores that length, how do you get that length? This is one way to, this is an easier way to get there. And the single dimension, we could say scores dot length gives you that length, but that's the total size. You have to do -1. So you either -1 or you don't include that last number and you don't put the equal sign there. Okay, so that's why it's needed. Another way to get the index here is you could do it this way. So you don't have to do it, but I'll show you. I can dim like row I as integer equals to scores. Okay. Score 0. It doesn't matter what the other one is. I think it's score 0. Yeah, I don't remember. There's a way you can get that number using the length. I know in Java, in Visual Basic, I don't remember, but there's another way. I thought it's the same, but you can get another. You can get the length as well from that column or row, and then -1. Maybe some other time when I want to figure that out. I know there's a way. Okay, so we got the row index and the column index, and then now we can just print out to the list box. Again, if you don't format it, it will look just like before. If you want to format, then the idea here is the same as the for loop down here. Okay, So you go back to the same thing as we did here. You would dim a string here, and then you would set the string, and then set that in here, just exactly same as before with the for loop. So the string formatting will be the same, exactly same. The adding will be the same. The location will be exactly the same place. The only difference you have here is just the loop structure, okay? And then you have to increment your counters. Okay, notice that when we, let's just say if I add it to the list box, so ls result dot items dot add. If you add the first item, which is the scores of row and column, you add the first to the list. Okay. And then now I'm still looping to the inner loop here. I need to increment my column every time. So below here, after I added that to the list, I need to go and say column is now column equals 1, plus equal 1, right? I increment that to column. So it goes from 0, 1, 2, and then it's done, exits out before it goes to the next row. Out here, then also need to now plus equal 1 for the row. I need to increment that to the next row, and so forth. Okay? So let me put this another line up here so we know that this is the beginning of this while loop. So I put here do while. So we know that's the do while loop. And this we have this, just row by row. We don't have that nice table look, but that's fine for now. Okay, so let's run this and see what it looks like. All right. So this is our for loop. This is our for each loop. This is our do while. I only see 3 though. Why is that? How come there are only 3 of them? Only shows the first row here. What happened to the second row? I mean, the system did not crash, right? I don't have any information it says crash or something, but I only get the first row data. What's wrong? I incremented my row count, my column or row. I did that. So it's not a loop. It's not an infinite loop either. Any idea what's wrong with this? So I'm not getting my second and my third row. The what? Yeah, exactly, right? Very nice. Because you did not set the column. Because the column is already at 3 when you were done. So when 3 in there, 3 is not less than the column index, which is 2. So therefore, the second time you come around, it would never go into the inner loop. Okay, it would skip that. You go to row 2, it will skip that, and it would never go in there anymore. So that's the tricky part about using inner loop and outer loop here. So you always have to reset your inner loop index after you're done. Okay, before you go to the next loop, either here, or either here, or up here. It doesn't matter where you put it. Okay, usually you put it down here, so you can say column is now reset back to 0 to start the next column. Okay, you can put that here again, so out here doesn't matter before the inner loop starts again. Okay, because whatever you set here, that will always get it will be kept, because this column here is outside. So you change this in here, the data will be retained even though you end the loop. So you just have to reset it. Down here you don't have to, because every time you run the for loop, it resets that for you automatically. You already reset it here, reset to 0 every time you run through this loop. Okay, so that is why this is much more favorable for looping arrays than this one. You can see the headaches in here. You get some debugging issues in here. And so now if you run this, it should now work, right? Except we just didn't format it. So here's the first row, the second row, and third row. Very nice catch. And to format that, you would just do the same thing we did with the string here. So if we just like copy and paste, for example, put out here, I want to reset my string. No, reset the string right before the first, right after the first loop, like right here. Reset that every time. You can do that, or after that, that's fine too. It doesn't matter. When you reset your column, it's the same place. And then you also want to add that into the inside the loop here. And then you don't add that inside here, you add that outside. So you put that out here after the first loop, you add that string to the items, and now it's formatted. Okay, so all you do is you build a string of the row of data. Once you build that, you're done of that first row. Then you can add it to the list so it looks nice, and then reset your string. So if you reset down here, so maybe it's wiser to put the string reset down here as well. So everything gets reset down the bottom. Right? So your code will still look clean. And let's see if that would print what we have expected. So you can see now, click run. Here we have our do while. It looks just like before. Okay, it looks nice and neat. Okay, so you can see how I did that using 3 different methods of loop: the do while, the for each, and then the for loop. Of course, you can also do the until. Okay, when you do until, just make sure that you swap the signs, the operator signs, and then you might want to also reset the initial numbers, because you are now saying the reverse of what you initially said. What that means is, like, if you do until, you would say do until row is greater than row index, right? So if you do until, this will be swapped, this will be changed. The opposite of this is greater than. Okay. If it's equal, then it will be not equal. If it's less than, then the opposite will be greater or equal to. So you have to know the reverse of these negative operators here. You have to negate the whole thing in order for the until to work. Okay, if you don't change it, if you don't change the sign, if you just change until here, then you'll see that this will never run, and you will get nothing out of that because it's false, right? It's already false. I mean, it's true already. It's true, but then because it's a false statement, so it will never execute. It says do until row is less than or equal to 0, or less than or equal to 2, which is row is 0. That's already true, and so therefore you stop. Okay. So in order for that to work, you have to change this to say do until row is greater than index. If you change that sign, so here I have until, I have a regular while. By changing that, I should have the same result back as before. Okay, so it's a little bit tricky when you use until in the regular do while, and you have to do a lot of practice just to make sure you understand how this works. Okay, it just takes a lot of practice. It's not because I can do so quick. No, it's lots of practice, and you'll see that this is only loop that you have in Visual Basic, the until part. You won't see that in other languages. I pretty much guarantee you that. You won't see that in Java and C++, C#, JavaScript. They don't have the until something that's true. Only in Visual Basic here. They don't even have the do while loop. They just call the do loop. Okay, there's a while loop, there's a do loop, and there's a for loop. And for each loop, but not undo until or do while. Yeah, as far as I know, this is the only one that have it. And it just makes things more complicated because you have so many options now, and they serve the same purpose, right? So why do you want to use until? Well, because it makes more sense for some people to read it that way. you keep doing this until this is no longer valid. Then you stop. Okay. And so instead of that, you do the positive. So do until is usually referred to as the negative test, the negative loop, and do while is the positive loop, right? Because do until means that thing is negative until it's positive, then you exit out. So it's a little bit weird how you think it, but if you just read in terms of English, then it makes sense. The do until row is bigger than this number. Otherwise, you keep doing that. Right? And then this is like, while this is less than that, keep doing it, right? Until it's greater than that. So it's kind of redundant to me when you think about it, but you do have those options there. So you have like do until, do while, you have the while loop, and then you have the for loop, the for each loop. So you have about 5 different loops in Visual Basic. And if you think about the bottom test loop, do until down here, and do while down here, you have 2 more options, a total of like 7 options here. So it gets a lot. Okay, I'll